Good day everyone, and welcome to the fourth week of the differential equations course. Here is the plan for today. Basically we are going to learn probably the most important theorem in the whole course, the Picard-Lindlov theorem of existence and uniqueness of solutions of differential equations. In order to understand today's lecture well, you need to review a few concepts. So if you do not feel very strong about continuity and differentiability of functions of several variables, then probably you should stop the lecture now and open your Calculus 3 lectures. Well, anyway, let me recall that in the first 3 weeks we learned that in general there is no method to solve any ODE, but there are some methods to solve large classes of ODE. And here is the Venn diagram of different classes of differential equations, right? So we have linear differential equations and separable differential equations. So these two classes, they have different methods of solution. These two classes intersect. So there exist ODE that are at the same time linear and separable. So those ODE can be solved by using either method. The good choice is usually the method for linear ODE. It is easier than the method for separable ODE. So besides, there is a large class of differential equations called autonomous differential equations, those that do not have the independent variable explicitly in the right-hand side. So they are separable. And autonomous differential equations can be easily recognized from their direction fields. So that's the beauty of it. And one more little thing that I would like to mention. So maybe I want to tell you this story about this probe that you see on the picture. So this is the Akatsuki probe. It was sent to Venus, and unfortunately, when it approached Venus, the main engine broke, and it couldn't enter the Venus orbit, and it just flew away to the space. And it went around the sun, and it went on just revolving around the sun for a few years until it approached Venus again just by chance. But then, in order for it to enter the Venus orbit, they had to apply the backup engine very, very carefully. So there was a very limited amount of fuel to perform the required maneuver to enter the Venus orbit. So in mathematical terms, what they had to do, so they when you apply an engine thrust, it means that you are giving your probe a certain initial velocity. But then once this initial velocity is applied, after this the motion is free, which means it must satisfy the differential equation. And basically the differential equation comes from the fact that everything obeys the law of universal gravitation. So what they had to do, they had to invent the right initial value problem so that its solution would orbit Venus rather than orbit the sun. And they were successful, and they actually did it. You can just Google the Akatsuki probe. It's a very inspiring story. But what I want to say is that the basic intuition and the kind of the ultimate goal behind all differential equations is that whenever you think of differential equations, you need to imagine the solution of an initial value problem. So it's not just for every practical purpose, you have your differential equation and you have your initial value problem, and whenever you solve an initial value problem, you can imagine the motion. So some like a probe is moving in the space according to the differential equation. So with this in mind, I'll stop now.